So what we have discussed in class, so we discussed about simple pendulum. Pendulum. So then recording of down the amount of right? No silence. Right. Right. So last week we discussed about simple pendulum. So can you remember the expression which gives the time period of the simple pendulum of length simple L, and it's been at a place where the gravitational acceleration is simple G. So what is the expression? I gave it to you. So it is T equals 2 pi square root of L over G. Right. So under what conditions this expression can be used to get the time period of a pendulum? What are the assumptions, or what are the conditions need to satisfy? No resistive forces must act on the pendulum, right? Then the angle of oscillation should be very small, right? So those are the main assumptions. So we derive this expression step by step, right? Initiating from the tau equals IR by expression, we did the derivation of this expression, right? So today, before we move on to the discussion of homework questions, there are some homeworks need to be discussed. I think there are some strange questions about YouTube. Venus questions right? So we are going to discuss that homework questions later, and also the structured essay questions. We completed hair separates practical, but we didn't discuss the structured essay question. Before that, practical again, right? So using this expression, we are going to determine the gravitational acceleration of the laboratory, right? So using simple pendulum, we are going to determine the value of G, gravitational acceleration of hand. Yeah. So we start with this. This is the expression we use. So in order to get linear graph, we square both sides of this expression. So in the left side, T square is there. So 4 pi square, because square graph L over G. So this is the expression we use in order to get a linear graph in this practical. So L is our independent variable. L is the independent variable which represents x-axis. T square is the dependent variable which represents y-axis of the graph, and the gradient is 4 pi squared over G. So if you obtain a set of readings for simple L and T square, then represent L from the x-axis, T by the y-axis, and plot the graph. The graph must be a graph must be a linear graph which passing through the origin of the graph, right? So from this graph, how you determine the gradient? So how do you determine the value of g? By looking at the expression, how you get the value of g after plotting the graph? We need to find out the gradient of this graph. We need to calculate the gradient of this graph. So how we get the gradient? Get the choose two coordinates which lies on the graph. Yes. So we didn't have the 0, 0. We didn't take right. So the first reading normally we are getting for some value of L. We can't zero the L. Here 0, 0 means L is 0, L is 0. So are you going to obtain a rating for where the length is 0? No. So you can extend this, but normally we plot the graph by joining the points we mark here. Mark the points here. That's why. Yes. Right. So that's a correct way. We are not taking the 0, 0 mark. 0, 0 when the 0 is 0, that's obvious, but we are not going to take it. In practical way, that's why you need to mention the 0, 0. Make a variant, sorry, graph, origin, definitely compulsory you need to write this 0, 0 coordinate at here. Otherwise, you can't say this graph is going pass into the origin. We never know. So that's right. Right? 0, 0 mark right. So take two coordinates which lies on the graph line and take the y coordinate difference and divide it by the x coordinate difference and get the gradient. Gradient of the graph. So gradient of the graph would be gradient simple m is equal to 4 pi squared over g. So g is given by the expression 4 pi squared over gradient of the graph. Right? So this is how we are going to get the value of g. Like some things. Right. So now we need to set up a practical to obtain this gradient, obtain this value. So what are the materials and apparatus you require to do this? So our topic is, our experiment is determination of the gravitational acceleration of the laboratory using simple pendulum. Right? Now tell me what are the materials and apparatus you are going to use in this practical? And first, locating pin. You need a you need a pendulum bob and string with length 2 meters. Here. A laboratory stand required. A meter ruler required in order to obtain the length of the pendulum. Yes, a measure instrument. Stop clock. You require stop clock or stopwatch. So what is the difference of clock and watch? Not a digital one. Clock is that large one. How to take that clock cake? Watch is a smaller one, which still the clock cake. Clock cake can hold the cake. Even clock cake can watch it. Yes. Here, body stop clock. Can watch it. Body. Right. Right. So you need a stop clock or stopwatch. Right. Then a simple pendulum, which includes a small metal bob and a string attached to it. Then what you require? A laboratory stand, meter ruler, and what else? Rotating. Locating pin or reference pin you require to locate to our conjugate of counting the oscillations. Yes, what else? Another small. We need a cork which are cut vertically, right at the center. But we have how you manage right? Okay. A cork, huh? The pin is underway. Take a body move, or the some bottles of wine, some bottles of lead. The Haladi body wooden piece of that. Standard practical monkey. Take a movie practical golden maybe cut vertical. Right? So this is the yes. Pendulum pieces pendulum string through the standard set high make a cork pieces string make up pendulum pieces make sample මුගිය පොස්කල් හැබැයක් මේක තියෙන්නේ. ඒ හැබැයි මැදින් කපලා තියෙන. පළු දෙකක් තියෙන. පළු දෙක මැද්දෙන් තමයි නූල යන්නේ. ක්ලෑම්ප් එක. නැත්තම් එහෙම නිකම්ම ක්ලෑම්ප් කරොත් මොකද වෙන්නේ? ක්ලෑම්ප් කරොත් එහෙම නිකම් බල ක්ලෑම්ප් කරනකොට මේක ස්විං වෙනකොට මේ පැත්තට යන්නේ ලෙන්ත් එක වෙනස් වෙනවා. මැදට එනකොට ලෙන්ත් එක වැඩි වෙනවා. මෙහාට යද්දි මේක කියන ක්ලෑම්ප් එක මේ පැත්තට යද්දි ක්ලෑම්ප් එකේ අර आर्म में के टच करके उधर लेंथ तक आगे गिरा मैंने लेंथ लेंथ तक ऐड किया मैं हाथ जगह लेंथ तक वेस्ट तो कॉक के यूज कर रहा हूं एक हारी देला मेरे के मैंने इतना भाई तो मेरा हारी फिक्स पॉइंट है तो मेरे लेंथ पेंडुलम लेंथ तक या मैं ओपे लोकेशन को लेंथ तक आना से now we can maintain the constant length of the pendulum while it's moving. So that's why a cork with vertically is required. Right? Okay, so this is the experimental setup. Make the experimental setup later. I look at this. This is the stand. This is the cork that cut vertically. Right? So you need to suspend the pendulum cork like this. Right. So here's the pendulum cork. Here's the pendulum cork. And you require another pin. This is known as the reference pin. You need to set the reference pin right at the lowest point of the lowest point of the path of the pendulum cork, right? So we have right. Okay. But we have make a along here cork make a stand set කරනවා. එදගේ පළු දෙක මැදින් තමයි ස්ට්‍රින්ග් එක අපි එකතුරු තමයි යවලා තියෙන්නේ. pendulum bob එක තියෙනවා. bob එකේ lowest point එක තමයි reference pin එක අපි set කරන්නේ. So this is the reference pin or locating pin. Right? So now we have a stop clock also. Stop clock take up. You know, like to set up it vertical. So string එක point කරේ. Close point again. Sometimes they, but I follow the guide, like practical guide. Yes. At the lowest point, you need to set it like that. Pin is vertical. The tip of the pin should be pointed up. Right. Okay. So now you need to swing this pendulum. So how you swing this? All the tapping current, local other. So we need to move this pendulum aside, right? For a smaller angle, less than 6 degrees or 6 degrees of the angle. You need to move this pendulum box and release it. Then release it. Right. Then you need to count the number of oscillations. How we count the number of oscillations? And you need to take the time taken to complete some certain number of oscillations. In this practical, we are not going to get the reading of the time period for a single oscillation, because single oscillation will take approximately less than 2 seconds. For a, if you take a 1.5 meter length of pendulum and you swing it, the time period of the pendulum must be somewhere about 1.5 seconds or something. So if the least count of the instrument, the stop clock, is 0.1 seconds, we are using. Right? So let's take the time period for a single oscillation is 2 seconds. So what is the random error with this measurement? How we get the random error? Error in time measurement over, like, as a percentage, right? So error in time measurement, error divided by the measurement you take. So delta T is 0.1, least count of the instrument. So measurement you took is 2 seconds multiplied by 100. So what is the answer? 10 over 2. So it is 5%. Is this acceptable? No. Anything the percentage error over 1% is unacceptable, right? So this is not acceptable. 5% is very high. So in order to reduce this error, what we need to do? We need to take, we need to increase this measurement. If this is like a 50 seconds, so what will happen? 50 seconds not here. This is 10 over 50. 10 over 50 is 0.2%. So we can reduce that error up to 0.2 seconds to 2%. Therefore, we need to take, in order to increase the time measurement, you need to get time taken for 25 or 30 oscillations. 30 oscillations to our time measure time measuring reduced random. So that's why we take here time taken to swing 25 oscillations at least. So how we count the oscillations? Like, suppose now the bob is at here initially, then you let it go. Right? For the first time, the bob is passing through this, passing over this reference pin. So is your counting is now going to start the counting? You need to count oscillation in descending order. We use a descending order counting here. You need to start from 3 to 10 and start 1 to up to 25. Right? So we use that method is straight away අපි කෙලින්ම මේක අතහැරියකම මෙයාගේ 1 2 3 කියලා මේක oscillation measure කරන්නේ නැහැ. We start with number 3 3 2 1 කියලා descending order එකලා then 0 1 2 3 කියලාමයි start current, right? So we have IVN. So when you let this mobiles to move, all right, first time it's pass current. All right, now we are not going to touch the stop clock at right now. Right there, I pass current for the first time. For the actual second time, they will pass current. Reference pin එක pass කරලා තමයි count එක start කරන්න ඕනේ right ඒ complete වුණාම තමයි count එක අපි 3 කියලා ගන්නෙ right අතෑරියා ඔන්න ගියාම එළිය ආවා right 3 then 2 1 0 right now you need to 0 කියපුවා මොකද නේ you need to switch on the stop clock and start the time measurement. Zero की होने पड़ता है. Why is that? Straight away zero नहीं पड़ता नहीं है. अभी oscillations what के अंदर let it happen. चुट्टा कोई तो दीला अभी यार प्रोडक्ट ऐसा गुरु करना. Right? We convert this into expected activity, expected process. अभी जानना now this moment the pendulum will pass the reference speed. अभी पढ़ी एंकर टाइम तो तीन पड़ी रिदम में गाने 3 तो मैं वाला 3 2 1 0 किया थी ना आप यहाँ रेडियो ला इन्ना एक एक्सपेक्टेड एक्टिविटी एक आपके लाभ है एंकर टाइम तो तीन और your reaction time will now improve so क्लॉक एक ऑन करने वाला 8 का हरियर मारे चार्ज मैं आप पिन का हरियर वो पे को पास करने टाइम में का तब वाले जब पूरे लाती एक निशा that will reduce the error of counting oscillations right time measurement එකේ තියෙන error එක අඩු කර ගන්න නැත්නම් ඔයා මේක අතෑරික මෙතන පාස් වෙනකොට clock එක on කරගත්තොත් maybe you cannot switch on the stop clock right where the bob is right at the point where the bob is passing the reference so ඒක පහුවෙන්නේ පුළුවන් මොකද ඒක එකපාර sudden activity එක sudden එක කරන්න වෙලා නැහැ so චුට්ටක් එකට swing වෙන දීලා oscillations තුනක් විතර ගියාට පස්සේ now start from the zero right and ඒක තමයි method එක so you are going to take time measurement for 25 readings 25 swings of the pendulum right so then use the meter ruler to get the length of the pendulum. So how we get the length of the pendulum? That length should be measured from the point where the string is connected with the core and to the point of the center of gravity of the pendulum bob. So length L should be measured from this point to center of gravity of the bob. So use meter ruler to get that reading. Then construct a table. Here, the length of the pendulum. So you can increase, you can start with the 2 meter length. 2 meter, 1 meter, then you have taken time for 25 oscillations. Then take time for 1 oscillation and get the t-square value. So suppose we are starting from 2 meters, so 200 centimeters. Now we need set of readings to plot the graph. So how many readings would minimum required to plot the graph? How many readings would we need 6 readings. You need to take another 5. So you can decrease or you can decrease the length of you can reduce the length of the pendulum. So we are going to reduce the length of the pendulum by 20 centimeters. So next length of the at the next turn the length of the pendulum has reduced to 180 and repeat the practical and take the time reading for 25 oscillations. Again repeat it to 160 centimeters like that. Take 6 readings. Then plot the graph. Right? And find the gradient of it. From the gradient, you will be able to get the value of the t. Right? Okay. So what are the important or special things we need to discuss here? So why you place this reference pin right at the bottom of the path of this pendulum? Why we can't place it somewhere here? After it oscillates, it stop at the, is that the main reason? So what is this position? This is the center of the oscillation, right? So where the center of oscillation is the point where this pendulum will have the maximum speed. That's the maximum speed at the center of oscillation, right? That means this pendulum will pass this reference speed at maximum speed at this position. That will reduce the uncertainty of time measuring. Okay, so you can recognize, now this pendulum bob has completed one oscillation. You can quickly recognize it. If the pendulum bob slowly pass that speed, pass on time pass doubt, so it will take a lot of time to pass if the speed is low. So that will increase the uncertainty of time measuring of the time period. ඉක්මනට පාස් කරා කියන එකට අත්දාලා එරේ එක අඩුවෙන් හොයාගන්න පුළුවන් ඉතවා. එයා මොකක්ද කනුවක් දෙන කනුව හිමි පහු කරනවා. ඒක අන්තිම මොහොතේ පහු කරන්න කිව්ව වෙලාවට ඇද්දි පහු කරාද නැද්ද කියන ඩවුට් එක ගොඩක් වෙලා තියෙනවා. අපි සම්ලි පාස් කරත් එහෙම. So that the doubt is very minimum. Time එක හරි minimum. එරේ එක minimum. So that's what happened. That's why you place the reference pin right at the bottom of the path of the pendulum. Right? Then the next one is this reference pin should be connect or should be set up very close to the path of the pendulum. So from doing that, you can identify that the pendulum will swing in a same plane, the same plane. So you need to maintain, throughout this practical, when you take a reading, you need to maintain the path of the pendulum, right? It must be swing at a same plane. It cannot go elliptical path. We need to maintain this pendulum is moving or swing on a plane, a same plane. So how do you certify that whether the pendulum is moving on a same plane or not? So by looking at the side ray, you can identify that if the pendulum is moving all over the place, so it is not moving in the same vertical plane. It is not moving in a vertical plane. Understood? Right, so now you know the purpose of using that cork cut vertically to maintain the length of the pendulum same or equal throughout the oscillations. Right? Throughout the make සම්පූර්ණ motion එකෙන් අපිට fix තියා ගන්න. Right? So what about using of right? So tell me this. Instead of spherical shaped pendulum bob, if you are providing a conical shaped pendulum bob, normally we use this type of pendulum bob. Right? But if we have given a pendulum bob like this, something like a conical shape. So what are the advantages and disadvantages of having a bob shape, conical shape? Yeah, so because it has a sharp edge, so you can locate the reference beam right at that point. So that will ease the counting of oscillations. That one advantage. Yeah. So you can easily get the center of gravity of this spherical shaped one. Center of gravity of a sphere is right at the middle. But you cannot locate the center of gravity of this conical shaped pendulum exactly. We do not know where is it. We can't say right at the middle because mass distribution is uneven. So that's the main disadvantage. Is one disadvantage of using a conical shape. Make a paper here, 2023, I think. They asked this. 23 years simple pendulum and make it 23 or 22. No? 23. Yes. Right? So in 2015, the practical was a bit modified. That question is included, I think, here also. They have used a laser beam instead of a reference beam. They have used a laser beam to identify the end of the oscillation. Oscillation is completely on the line. The laser beam made a reference beam there for it. When the laser beam is cut from the pendulum bow, so that will mark as a reading. So give a question right. So write the topic. Determination of the acceleration due to gravity. Practically. Right topic. Determination extra. Acceleration due to gravity using the simple pendulum. Determination of acceleration due to gravity using the simple pendulum. Using the simple pendulum. Right, then materials and apparatus. Materials and apparatus. Write the materials and apparatus. A simple pendulum. Locating pin. Locating pin. Meter ruler. A meter ruler. A meter ruler. A stopwatch. A stopwatch. A cork. A cork. Cut vertically. A cork cut vertically in the middle. Cut vertically in the middle. A cork cut vertically in the middle. Watch out. What do you mean? What is it? Right. Then the theory. The time period of The time period of a simple pendulum. You know, a laboratory stand, a laboratory stand. Make it a sort of stand. We are not family. Any other अभी तो आपकी फैमिली का फैमिली के लिए बड़ा लोग आ रहे हैं ठीक है बताइए the time period of a simple pendulum of length simple L swings the time period of a simple pendulum of length L swings in an environment where the acceleration due to gravity is simple g right. Come on. P equals to 5 square root of L over G. P equals to 5 square root of L over G. P equals to 5 square root of L over G. Like now, here's the we need to arrange this expression, like the square the both sides and get the expression as y equals mx. Then draw the graph and also the gradient. Right now, right. Right. Everything is on there. ये कौन में यार वेरिएंट का पिक में और पिक करना पॉइंट्स देगा need to know the right numbers. This one. Right. Then a method. Write the method. Method. Right here. Pass the pendulum string. By the method, pass the pendulum string. Pass the pendulum string. Pass the pendulum string through the pass the pendulum string through the core. Pass the pendulum string through the core and suspend the pendulum from a stand. The pendulum from a stand. Stand. Fix the locating pin. Fix the locating pin. Fix the locating pin vertically below. Vertically below and close to the lowest point of the lowest point of the path of pendulum walk. Path of pendulum walk. Pull the bob, pull the bob, pull the bob, pull the bob, pull the bob. Aside, pull the bob aside. Till it incline. Till it incline. Till it incline. By a small angle to the vertical. By a small angle to the vertical. Small angle to the vertical within brackets. 5 degrees or 6 degrees. 5 degrees or 6 degrees. Close bracket. Release the pendulum to make it oscillate in a vertical plane and using the stopwatch measure the time for 25 oscillations. Measure the time for 25 oscillations. Note down the value of simple L. Note down the value of simple L of the pendulum from the point of suspension down to the center of the pendulum bob. Down to the center of the pendulum bob. Down to the center of the pendulum bob. Repeat the experiment by varying the value of simple L. And obtain about 6 readings, 6 recordings, or 6 readings. 6 readings, right? Plot the graph T squared versus L. T squared versus L. Calculate the gradient of the graph. Obtain the value of G. Obtain the value of simple G. Value of simple G. Using the expression given under theory. Right. So special facts about this practical. Special facts. Right. Special facts. And since the formula T equals 2 pi square root of L over G. 2 pi square root of L over G is L over G is valid only when the angle of oscillation is small. The angle of oscillation is small. we need to maintain small angles of oscillation. Small angles of oscillations. Small angle of oscillation. Small angle of oscillation. Throughout the experiment. Throughout the experiment. Locating pin should fix at the lowest point of the path of the pendulum bob. Since the speed of the pendulum bob is maximum at that point, the uncertainty with time measurement is reduced. Within bracket, time measurement is sharp. Time measurement will be sharp. Time measurement will be sharp. Next step. In order to activate the stopwatch, when the pendulum bob passes the locating pin, start counting in the descending order. Start counting in the descending order. As the examples, 3, 2, 1, 0, again 1, 2, up to 25. Up to 25. Right? After this, when the person who starts the stopwatch gets used to this rhythm of the pendulum spin, get used to this rhythm of the pendulum spin. Therefore, personal error becomes minimum. Therefore, personal error becomes minimum. Minimum. Personal error becomes minimum. Personal error, it can reaction time negative. Mainly reaction time. Siddhiya දැකලා ඒක react කරන time එක නේ අපි ඒක sudden වුණොත් වඩා අපි expected එකක් නම් අපි අත්දාලා react කරන්න ඕනේ. So මේ ඒක තමයි right. Now look at the question. Structured essay question 2006 A level. The question is given in this paper. Parallax error. Structure essay 2006 question. Take the question maybe now. First question is equal to 2006. Question again, write the answer. So you have the paper on Sunday paper, you have paper up. 4 structured essay questions and 4 essay questions. For 3 hours. No, evening, 3 to 6. Right? Like this following Sunday. No. Then go another. 30th. 31st. So no essay questions or structured essay questions on simple harmonic motion, right? In simple harmonic motion, only mechanics. Mechanics තමයි එන්නේ. No, essay paper එකක් first paper එක essay. 3-hour paper, 4 structured essay, 4 essay questions. Need to answers. Yeah, only mechanics. And measuring instruments, yeah. Measure. Unit 1 and 2. Up to mechanics. MCQ events and then. Yeah. 3 to 6. Take it. So you can have that classroom later. Yeah. Yeah, I'm hiding very. Yeah, I know. I'm hiding. Take it. Yeah, I'm the solution. And physics and Right. Finish. Good. Right? Finish. Correct. You want WFD means for this structured essay question. Structured essay in you're the one, right? See, part C, you're right. Part C and D. Simple. how you get the length of the pendulum? So length of the pendulum consists of the length of the string plus radius of the Right. I think time is enough for this question. Look at the question. This is a structured essay question given in the paper 2006 A11. Right. A student plans to find the acceleration due to gravity in the laboratory using a simple pendulum. Right. So that's was his plan to find the acceleration due to gravity. Write down an expression for the period of oscillation t of the simple pendulum in terms of the length L of the pendulum and the acceleration due to gravity g. Capital T equals to pi square root of L over g. Rearrange the above expression in the most suitable manner in order to obtain a value for g by plotting graph. So that expression t squared equals 4 pi squared over g times L. When taking readings for capital T, student keeps a reference pin directed at the point B as shown in the above diagram. State why the directing of pin at B gives better accuracy of the time measurement than directing at A, because the speed of the bob is maximum at B. So therefore, time measurement is sharp. Right? That must be the answer. Speed of the bob is maximum at B. Done. At B, you can point B can measure that. B is the lowest point. No, actually, they know B is the lowest point. Lowest point, you whatever that man. That is right. Part B, when the student measured the time for only one oscillation, his reading was 2 seconds. If the instrumental error in the time measurement is 0.1, determine the percentage error of the value of period of oscillation. So, like I did previously, the error in time measurement is 0.1 over 2 times 100. So 5%. 5% is a 1 second. 5%. Part 2. Instead of measuring the time for one oscillation, he measured the time for 25 oscillations. And the value obtained was 50.2 seconds. Determine the percentage error of the value of the time measurement. So now again percentage error, time error is 0.1. Now the measurement has increased to 50.2. So 10 over 50.2 Approximately 0.2. Then I'll give you an answer to nearest decimal point. I think 0.19. Oh, nearest decimal point, they're going to make approximate 0.2. 0.2. Part C. The student used a uniform metal sphere of radius simple r as the pendulum bob. The length L he used as the length of the pendulum is shown in the diagram. After plotting t square versus L, he found that the gradient was 4. Intercept was 0.04. Rewrite the expression in part A in terms of capital L, R, and G. So here, the above expression L is the length of the pendulum. So in this case, total length of the pendulum is equal to the length of the string plus radius of the sphere. Total length is capital L plus simple R. Huh? Sorry. Why? What is capital L? Capital L. L value of L is not required. Yeah, we can get it. 2 5. Instead of simple L, you can use L plus simple R over G. So then square the expression 4 5 square L plus R over G. Right. So need to rearrange this expression. So 4 5 squared over G times L plus 4 5 squared simple R over G. So this is the expression. Determine G. So how you determine G? So if you plot a graph T squared against capital L, so this graph is a shape of y equals mx plus c, a linear graph with positive gradient and positive intercept. So what is the gradient of this graph? The gradient they have given it is 4. Gradient equals 4 pi squared over g. So 4 cancel and now so g is pi squared. Pi is 3.1. 9.61. ms minus 2. The value of g 9.61. How they get 9.61. Right. Determine the radius of the sphere. So how do you get the radius? The intercept of the graph is 4 pi squared r over g. So what is the value of intercept given? 0.04. So what is this 4 pi r squared g? What is the value of this 4 pi r squared? This is the gradient. Yeah. 4 pi r squared is a gradient. It is 4. Gradient is 4. Make it the gradient. 4 pi squared over g is the gradient. It is 4. So r is 0.01 meters. 0.01. Right. Finally, the student observed that the amplitude of the oscillation gradually decreases with time and the bow finally comes to rest due to air drag. He repeated the above experiment with a wooden sphere of the same radius, which bow would take less time to come to rest. Give reasons for your answer. So out of wooden and metal globes, which bow is comes to rest first? What is your thoughts? Wooden one or metal one? Metal one. Behind you, metal one or wooden one. Suppose you are swinging a metal bob and metal bob and wooden bob. Which come first? Which come? the rest first. Metal. Why is that? Reason? Because it is metal. Okay. First thing, why it should come to rest? Why is that? Because of the resistive forces, air brakes, and energy losses. Right? So the pendulum which comes to rest first should have the minimum energy initially. So out of those two, wooden and metal box, which one have the minimum energy? We give same amplitude. We give same height. Both of them. Which one has the small? Wooden one. Wooden one has the small energy initially, right? Energy. The energy stored is less is or small is the wooden one. So it comes to rest first. So you can either say the rotational inertia is less of the wooden sphere. Rotational inertia is less, so it can easily comes to rest when the rotational inertia is less, right? So energy stored in the wooden pendulum is less than that of the metal pendulum. So therefore, it comes to rest first. That must be the answer, right? So either you can say the rotational inertia is less in wooden pendulum. Right. So you can do the next question as a homework. So this is 2015 A-level question, right? It is a creative one. So this is actually not exactly practical we were discussing. The base is practical, the theory is about the practical, but they have modernized the practical, right? Okay, so then go back to the hair separators tube. So, right. So we have got the hair separators. Structure is a question. Where sound now? Yes. So I hope all of you have answered the question. So I think 2 weeks before we discuss the practical, there are separators. Right. Now see the question. Right. Look at the question. An experimental setup of hair separators used in school's laboratory is shown in figure 1. As shown in XW and XL represent the heights to the marked capital L of the relevant indicator from the water and liquid surfaces in the beakers respectively. So can you see that capital M mark clearly? I hope so. We have M is there. So this is the known experimental apparatus, but a hair separators, right? Hair separators not it. So two scales are given, and there are two liquids. One is water, the other one is some kind of a liquid, and there's a rubber tube and clip there. What is the purpose of using a clip in hair separators? What is the purpose of using a clip? words. You can write a reaction. Or ban clip video clip reaction. So still not they are not technologies not up to that point. They have a reaction now. But they can in words, yeah. You need to you must be able to convert that reaction into words. Otherwise, that will be to maintain constant pressure, right? That's okay. To maintain pressure inside the tube is constant. One answer. It is a. So these are the given answers, right? To maintain liquid columns in the arms of the hair separators, right? So you need a clip. You should tight that clip in order to maintain the liquid columns in that hair separators. And the cover clip the first answer is to maintain the liquid column in the arms of the hair separators. The second one, to maintain the liquid heights at a constant value. No need to write all the answers, but these are the valid answers. And they have mentioned in the marking scheme. Or to maintain the pressure inside the tube at a constant value. Or to block the air going into the tube from the outside. To block the air going into the tube from the outside. Right? So if you have, if you wrote one of these answers, you have a 1 mark for that answer. Right? So we are going with the marking scheme. Going through the marking scheme, right? Then the densities of the water and liquid are dW and dL respectively. If HW and HL represent the heights of the water column and the liquid column in the glass tube as measured from the mark capital M of the respective indicators, derive an expression for HL. That is very important. Derive an expression for what? HL. Which means you need to subject HL as the final answer. You need to subject HL. You need to write an expression for HL, right? Okay. So what is the relationship? So as you can see, the pressure at the outside. If you take the water beaker, pressure at this water surface is equal to the atmospheric pressure. Atmospheric pressure. So you can also write pressure at the same level inside that tube is given by the pressure inside the tube P plus HW plus XW. So why we need to add XW? Because these heights are measured from the level capital M mark from the capital M mark to the meniscus. Method HW can a capital M mark to the meniscus. So you need to add the height of the indicator in order to get the total height of the column. Yeah. No. Common interface is not the M. Right, me balanda. So mark M is there. When a mark M. Medinata measure the liquid column where the may also may height is HW. So you need to get the height of the liquid column from this point onwards. So height of the indicator is XW. So HW plus XW is the height, actual height of the or total height, the total height of the water column. Yeah, measure කරලා ඉතින් මෙතන තමයි මේ HW measurement එක කරන්නේ. ඒකම මෙන්න මේ length එකේ add කරන්න ඕනේ. ඒ length is HW. තේරුණාද? So equal කරන්නේ the pressure at this point is equal pressure at here. Pressure at this level, pressure at this water surface is open to the atmosphere. So pressure at this point is equal to the atmospheric pressure. So the pressure at here, HW plus XW, dWg, right? So pressure at point here, pressure is also equal to the atmospheric pressure. So in this section, this is not necessary to write these two expressions. Right? Make over in a hand. But you can make any expression so you can equal the pressures now. P plus HW plus XW dWg. P plus HL XL dLg. So if you have wrote this expression, you have a 1 mark. So you can start from here. Straight away you can equal the pressures without writing these two. You would have one time. Sorry. Again, P cancels, G also cancels. We need to subject HL. Divide all these terms by DL. X W plus HW dW over dL. Right. So expand the brackets. dW over dL times HW. XW times dW over dL. Take this XL to the other side. So final expression is this. HL equals dW over dL times HW. So this is the final expression, right? So they have expected only two lines, this one and the final expression. If the expression is correct, you have obtained the correct expression, you have a 2 marks. One for this statement, the other one for the subjective HL. 2 marks there. Answers are given. Right. Question number 3. If the expected heights of the liquid column and the water column are significantly different to each other, more attention has to pay on the one height than the other when planning out the experiment. To take a set of readings and plot a graph. What is the height to pay more attention? May I have heights again? What you need to pay more attention? Larger height to smaller one. In order to get the set of values, when you take this liquid columns up, what do you mean this? Large height. Why is that? Yeah, so we need to look at the larger height because, right, the water column will be the one which comes first to this area, right? If we මේක දිහා බලන්න. අපි liquid column එකට ගත්තොත් එහෙම so ඒ වුණාද? So this water level will come to this curved path and maybe mix with the liquid. Right? So you need to pay your attention to the height of the water column, the large height. Right? So the answer is large height. The reason is it will reach the maximum height of the tube first. It will reach the maximum height of the tube first. But then, every time after changing the heights of the liquid and water columns in tubes and closing the lid, you need to make another adjustment before taking the measurements with regard to new heights. Write down the experimental procedure which you should follow to make this adjustment. So, what is the experimental procedure? You need to readjust the tips of the indicators that it just touch the liquid surfaces, right? So indicators have to be readjusted. Jan says indicators have to be readjusted. Indicators have to be readjusted until they touch the surfaces of the water and liquid levels. Until they touch the surfaces of the water and liquid column. Part B. The apparatus shown in figure 2 can be used to vary the air pressure inside the tube of the Hairs apparatus. The system works with Bernoulli's principle. Now they have the Bernoulli's principle to the Hairs apparatus, right? So this is a another modified version of the practical. So instead of using that, instead of sucking, they have used a tap tube and water supply to get that liquid columns to right. Right, then the air pressure inside the tube T can be changed by adjusting the speed of the narrow water jet passing through the section X of the apparatus with the help of the tap. The position capital A of the apparatus shown in figure 2 can be connected to the position A of the rubber tube shown in there. Make a set rubber tube. Then making liquid columns. Can you explain the mechanism of this? For the way I liquid columns make tap pick up in the liquid columns to the yes, apparatus. So when you open the tap, the speed of the water at the point X, that narrow area, at the narrow speed of the liquid is there's some sort of a speed there, right? So that liquid has a speed. Due to the speed, the air column also moving with that speed. So the speed of the air column gets increased at that point, the narrow area. Speed increasing means the pressure is low at that region. Pressure is low. Pressure inside the Hairs apparatus is now greater. Pressure at the narrow water jet area, air pressure at the narrow area is low. When there's a pressure difference, the air flows from high pressure to low pressure. The pressure in the air inside the Hairs apparatus will now go towards the narrow area. Right? Hair apparatus pressure liquid column pressure. right? To balance the pressures, the liquid columns goes up. So that's the mechanism. Write down the procedures used in hair separators available in the school laboratory and improved version of the hair separators mentioned in part B when establishing the liquid columns in tubes. So hair separators used in the school. What is the mechanism we use to establish the liquid columns? You need to suck the air with your mouth. Syringe, right? That's okay, fine. As answer in the current conditions. But in this 2018 question, they have not allowed the marks for the answers in the syringes. They have executed the answer which the sucking with the mouth is the only answer they have considered, right? Now it is okay. Syringe in a couple of syringe use school practical guide. So the professors, the second panel at that time, they are not flexible to thoughts of the teachers. Now the people has changed. So therefore, they will only stick to that practical guidebook. Guidebook answer. So syringe is also fine. Like that by looking at the practical here, they're given. There's no syringe here. But you better get better. So what you need to do? The only instrument we have is your mouth. You need to suck the air out. So hair separator is available in the school. The method is sucking with mouth. Right? Improved version of the hair separators. How you establish the air columns? Sorry, water columns. Establish water columns. Make it one again. Make it more established. Right. So adjusting the speed of the water jet or adjusting the tap. Adjusting the tap. Adjusting the tap. Right. Give one main advantage of using improved setup mentioned in part B over the apparatus generally available in the school laboratory. The advantage one main advantage having a tap and water supply instead of sucking the air with your mouth. Hair separators pressure. So what happens? The liquid is a toxic one. Can you use a mouth and suck the air out? So you cannot use this. You cannot use this setup given in the school in order to measure the density of a toxic liquid. Toxic, but you can use this improved version too. They do the practical with using a toxic one. Cutting to the net, right? So answer is sucking is not necessary. Yeah, you can find just the air column, height of the air column. Like that's also our answer. Sucking is not necessary. Oh, relative density of toxic liquids can be determined. Or poisonous liquids can be determined. The height of the water column can be set to, the other answer is, the height of the water column can be set to a desired value easily. You answer. Yeah, desired value easily. for a set of quality distributed data points can be observed. A set of quality distributed data points can be obtained easily. Part C. A graph plotted using a set of readings obtained from the improved apparatus mentioned in P above is shown below. The graph shows the variation of the heights HW and HL of the liquid columns for water and sulfuric acid respectively. In this experiment, you are provided a scale which can measure the length with an accuracy of 1 millimeter. What is the maximum fractional error associated with HW measurement? So how we get the maximum fractional error? Maximum fractional error is with the minimum length of the HW. So what is the minimum length of the HW they have taken? 1 millimeter. 1 millimeter is the error. What is the minimum value? Look at the graph and tell. What is the minimum value? Is it 9? Is it 90? Oh, 90? 100. 1 square is equal to, yeah, one square is equal to, I think, yeah, 10. So 90 for 140 into 5 squares again. And I could square got 10 here, right? So 100. 1 over 100. Right, so this is the fractional error. Fractional error is 0.01. Fractional error. Finally, using the 2 points of the P and Q on the graph, calculate the relative density of sulfuric acid. So if you plot the graph, what is the gradient? Gradient is dW over dL. Density of water over density of liquid. So find the gradient. What are the 2 points? 480 is x-axis. Is that? Yeah. 480 point x-axis. 270 minus 80 on the y coordinate difference here, right? Power of 10 is minus 3. 480 minus 130 on the x coordinate difference here. Power of 10 is 10 to the power minus 3. Because all you have a value of 90 or 19 or 35. Right? So this is not the final answer. So this is the reciprocal of the relative density of the liquid. Question asks to find the relative density of the sulfuric acid. Right? So relative density of sulfuric acid given by the dL over dW. dL over dW. Make a reciprocal. So it is 35 over 19. Which is 1.84. 1.84. Right. So that's it. So we have a hair separator question. Question in 2009 L question also. But there's a small problem here. That in that question they have included the surface tension also. Right, and the middle part, onwards the middle part, they have included the surface tension. Right. So, gas separators practical gas separators in use. Eva Sunday in the school. Hydrostatic swelling experiment structure fluid dynamics structure practical normal. essay questions වල බලන්න මේ work energy, rotational motion, hydro and fluid dynamics. So you have to know questions of the basic essay question. No choice. Other thing you need to answer all these questions. Alright, so now we can have the interval. So since 6:40 we are going to start again.